Alright, my dear children of class 11 science, let's continue deriving Poiseuille formula that we were deriving in the last YouTube video. And children, for your information, in the last YouTube video we have done up to this equation. These three equations we had derived. Now using these three equations, okay, we can find the value of A, B and C. And that value I substitute in equation number 4. And that makes the derivation of Poiseuille formula. Okay. Now, in order to calculate the value of A, B, C, let me just see equation number 5. So what is equation number 5? A plus C equals to 0. So if A plus C is 0, then A can be written as minus C. Yes, because plus C, if I take it on the right hand side, it will be minus C. Now this A equals to minus C. Now I substitute in equation number 7. A equals to minus C, I substitute in equation number 7 so that you can calculate the value of C. So I write down now, therefore, from equation 7. So let me substitute A equals to minus C in equation number 7. You know what is equation number 7? Minus A minus 2C equals to minus 1. Now A minus A is already there, but what is A out there? Minus C. So I replace, there is already minus sign, so A equals to minus C. Minus, there is already 2C equals to minus 1. Now minus minus plus C minus 2C equals to minus 1. Okay, let me just do this side. Now C minus 2C means minus C. See, C minus 2C is minus C equals to minus 1. So this minus minus cancel out. So we can see finally C equals to 1. So see, what is the value of small letter C? 1. Now this value of C, if I substitute in this equation, that means C, A equals minus C means now C is 1. Then A equals to what? Minus 1. Because A equals to minus C. Now this C, if I put out here, then A equals to minus 1. So we got the value of C 1 and A minus 1. Now this value of A and C, now I substitute in equation number 6. Now I'll take equation number 6. You know what is equation number 6, children? Minus A plus B minus 2C equals to 3. Now in this equation, I'll substitute the value of A and C so that we can calculate the value of B. Okay. So A minus A equals to what? Minus 1. So I put minus 1 plus B, I write on same because I need to calculate B. 2 into C is how much? 1 equals to 3. So minus minus plus 1 plus B minus 2 equals to 3. Now 1 minus 2 is minus 1. So I write on B minus 1 equals to 3. So B minus 1 is 3. Then B equals to 3 plus 1 because I take this 1 on the right hand side plus 1. So finally you can see B equals to 4. So children, I got the value of B, that is 4. And I got, we know the value of A is minus 1 and C is what? Plus 1. So finally I put this value of A, B, C now in equation number 4. So I write down from equation 4. Do you know what is equation 4? Equation 4 is nothing but Q equals to K, okay, eta to the power A, R to the power B and P by L to the power what? C. So this is equation 4. So let me substitute the value. I write K right now. Eta to the power A. A means what? A value we have already calculated minus 1. So I write on minus 1. Okay. R. Now B means 4. I write on 4 into P by L. Now C means 1. C equals to what? 1. So let me further simplify this expression. Now I can write this expression as K R to the 4. P1 is P only. Now eta to minus 1, if I take in the denominator, it will be eta, and L is in the denominator with power 1 means L. So Q, the rate of volume of liquid, means the volume of liquid flowing per second. Q is equals to K R to the power 4 P by eta L. But what was found by the Poiseuille, okay, and substitute the value by experimental value, and the value experimentally value which was considered by Poiseuille of K is considered as pi by 8. So when Poiseuille performed the experiment, okay, the flow of liquid through a pipe, the value of K was found to be was considered to be how much? Pi by 8. So K is constant. Okay, that's why the formula that we can now write with K equals to pi by 8 in the expression is given by Q equals to K means pi r to the power 4 p by, now this 8 will be in the denominator, it will be 8 eta L. So children, look at the formula now. The formula is pi r to the power 4 p by 8 eta L. So this is the formula that measure the volume of liquid flowing per second, that is the rate of discharge in through a pipe, is given by pi r to the power 4 p by 8 eta L. So children, this particular formula is called Poiseuille formula, and this formula which we have derived is also used to find the viscosity of the liquid, because when you know the rate of flow or volume of liquid flowing per second, okay, then we can calculate the viscosity of liquid. But the same formula I am going to rearrange in this manner also. So I write P only. Now this pi r to the power 4 I will take in the denominator. So I write on 8 eta L by pi r to the 4. Yes, the same expression I can write this way also. Q equals to P by 8 eta L by pi r to the 4. Now the reason why I am writing this formula in this manner, because I am going to compare this formula now with the very famous equation in electricity, and that is called law known as what? Ohm's law. And you know Ohm's law, this is the relation, okay, and Ohm's law, if you look at the Ohm's law measure current, and current I equals to what? B by R. I is the current flowing through the conductor, is given by B by R. Okay, now if you compare this relation with the equation of electricity, which is called Ohm's law, then we can simply see the term, this particular term in the denominator is similar to what? R. Similar to what? R. Now similar to R means this R is the resistance, okay, that means this particular quantity eta 8 eta L by pi r to the 4, okay, is actually known as viscous resistance. This term is actually known as what? Viscous resistance. Because you know, children, when the liquid flows, there is some obstruction, some opposition offered by the force exerted to each particle of the liquid at every layer of the liquid. Okay, and this is actually measured by the factor 8 eta L by pi r to the 4, which is equivalent to the resistance according to Ohm's law. This is a relation of Ohm's law. We can also call this quantity in the denominator as viscous resistance. Also called what resistance? Viscous resistance. So children, viscous resistance is given by R equals to 8 eta L by pi r to the 4. So in case of Poiseuille's formula, the viscous resistance is measured by this formula. And at the same time, children, from this relation we can make a conclusion that this viscous resistance increases with the increase in length of the what? Pipe. Means if you take a pipe of longer length, more viscous resistance. And this viscous resistance decreases with the increase in the radius, because resistance and radius are inversely proportional to each other. But viscous resistance also depends upon the coefficient of what? Viscosity. Which means it depends on the coefficient of viscosity, which increases with the increase in the viscosity of liquid. Means when viscosity of liquid increases, viscous resistance also increases. That's why I'll give you one simple example out there. I take glycerin and I take water. One is glycerin, another is water. Glycerin is also a liquid, water is also liquid. Both can flow through a pipe. But glycerin listen carefully, glycerin offers more resistance, viscous resistance than water. You know why glycerin offers more viscous resistance than water? Because the coefficient viscosity of glycerin is more than water. Means more the coefficient viscosity of any liquid flowing through a pipe, more the viscous resistance. That's why between glycerin and water, glycerin offers more viscous resistance than water, which flows through a pipe. So children, I have made the complete explanation of Poiseuille's formula for the flow of liquid through a pipe. Okay, and even we derive the rate of volume of liquid flowing per second through a pipe, and the formula is this much. Okay, and even we measure a very important term that is called viscous resistance. Okay, now in the next YouTube video you learn a very important theorem called Bernoulli's theorem. But before we come to the Bernoulli's theorem, so we try to understand the different energy of a flowing liquid, because when a liquid flows, there are number of energy which is possessed by the flowing liquid, and that we learn first. Then after we go to the Bernoulli's theorem, and that you learn in the next YouTube video.